guys, this is the coding teacher, and I'm here to teach you how to code. In this episode, we're going to pick up right where we left off with Flappy Bird, and what we're going to do first things first, is I'm going to go here, but let me look at what I have actually. So that delay, it takes freaking forever to show the first pipe, so I'm gonna get rid of that. Okay, I'm gonna lower that delay a little bit. In order to do that, I'm gonna go to main and first lower the set time up real quick. And before waiting these 2600 milliseconds, I'm gonna do this whole same thing again. So I'm creating the pipes array, generating a random pipe set, I'm pushing it to the pipes array, and then I'm waiting. I'm doing a set interval, 2600. So that's how I want to kind of like fix this issue. There we go. So every time I reload, I have a pipe set coming right away. Let me see. Just got a text message. Let me see if it's important. Nope. All right. So next thing I want to do, I want to get rid of this god-awful alert. It was an awful idea. So let me see what I have here. Okay, so this function detect collisions is something that shouldn't necessarily be in the main JS. It's probably something that should be in the bird file, because it's something that's intimate to the bird. It's just detecting its collisions against the pipes, and the actual alert happens right here. So I'm going to move this function to the bird file, and because I'm going to move this function to the bird file, I'm no longer going to have access to it here. So what I'm going to do is, whenever there's a collision, I'm going to update this variable right here. So I'm going to have the bird save a piece of state to determine whether it's dead or not. And that state, will be useful for many things, like for example to render a game over screen, to stop the bird from being able to jump, and so on and so forth. I'm gonna take this out of here, and I'm gonna grab this function detect collisions, cut it out of here, paste it into bird.js as part of the prototype. My function there. It doesn't need to take the bird as a parameter anymore because it's part of the prototype. So what I can do is replace all these with this. Okay, this one was wrong. All right. I'm alright with this collision. If I wanted to be more of a perfectionist, what I could do is create something like this. Look. Essentially, right now, what I'm doing to detect collisions is I'm detecting like this point and this point, right? If I wanted to be real precise, I could detect this point and this point as well. So I think I might do at least this one. I'm gonna do at least this front one. I'm gonna call that alpha 2, beta 2, right? And what are the coordinates for that point? Pretty simple. Alpha 2 is equal to this dot x plus, we'll measure it right here. Just gonna eyeball it. 43. I think odd numbers are bad luck, so I'm gonna say 44. And then beta 2 is equal to just quite simply this dot y. It's the same coordinates. Okay, so I'm gonna add that point up here. Alpha 2 equals this dot x plus 44, and then beta 2 equals this dot y. And now I'm gonna add that condition to these two. So if it's a high pipe, I want to check this one and this one. There ain't no way I'm hitting a high pipe with this one, right? It's either, you know, if for a high pipe, basically if this one is in, then this one is already in. So I'm going to add this condition for the high pipe. So what I got to do is or alpha 2 is greater than 0 and alpha 2 is less than x1 and beta 2 is less than y0. And for this one, what I want to do is similar thing. Actually, the same exact condition applies. No, it's not the same exact condition. I gotta change this one of beta 2 greater than beta 2. All right. So now, okay. So I have my detect collisions, right? If I go and back and reload this, probably not gonna work because I'm not calling it anywhere. Exactly, so I can fly through pipes again. Why? Because I moved this function to the prototype and I'm never calling it. Okay, no longer needs to take birds. All right. So, where should I do that? Probably gonna move the gravity stuff to the very beginning so that it always happens. And then I'm going to check the collisions. So this dot detect collisions pipes, right? It requires the pipes, so I have to pass them. But in this function, I don't have them, so I got to receive them from whenever I call the update method in main. Bird.update pipes. So whenever I call bird.update, I got to pass pipes so that I can see if there's a collision. Detect collision pipes, and right after detecting collisions, I can say if this.dead return. I don't animate anymore. Okay. So that's something. And I can still jump. But let's make sure that this is working inside. And then right here I can do if bird.dead log oops. And we're gonna do a return statement right here, so it freezes the game. So it just doesn't. If we return from here, then it doesn't get to the request animation frame, and it doesn't run another tick of the game. It's not working. So we're gonna figure this out. Oh crap. Here's what we're gonna do. If we detect collisions, then this .dead equals true. We're never actually, we're calling the method, but it returns a Boolean variable, and we do nothing with it. There we go. So now, whenever we, this turns out to be true, we're setting this .dead to true, and I'm not sure this is doing anything right now. I don't think it is. Exactly what I wanted. I wanted to, before I made that change, I would have had to, the bird would have had to go in all the way until one of these 2 points up here was in contact with the pipe. Now I've fixed that. It's a lot better. Next thing that I want to do is basically I want to make it so that when I hit spacebar, the bird's inclination kind of like goes up, right? And then it's at its maximum point right after I hit spacebar. Like each frame, it lowers, inclination lowers a little bit as he's falling. And as the bird continues to fall, the inclination gets deeper, down and down and down until he's like nosediving, and until I hit spacebar. As soon as I hit spacebar again, he's facing up again. So basically what I need to do is think of a way to relate the angle of, first of all, like look up how the hell do I rotate things with a canvas, right? In Canvas, how do I rotate an image? That's one of the things that I require. And the other thing that's needed is to find a way to relate the angle of rotation to the velocity y. So let's go ahead and Canvas HTML5 rotate CTX. The first time I did this, it took me like a good 30-45 minutes to figure out everything I needed to do. So no thank you. Let's see here. Okay, this looks promising. Here we go. So you first got to translate to the center, right? So let's actually analyze what this is doing. I'm filling the rectangle, X and Y. So if I want this guy to rotate on its axis, I'm just gonna choose numbers for this. It's dumb that they're making everything into a formula. All right, so if I want to rotate it on its axis, first I gotta translate. I don't think it's the canvas width divided by 2. I gotta translate to wherever the center of this guy is, which is, if rect width is 150, the center of the x-coordinate is 100 plus 75. So 175, and the height is 100 plus, let's change this to 80, 100 plus 40, which is 140. All right, so let's translate that. And here's the missing piece. I gotta do ctx.save before I do these things, and then ctx.restore. And I think, why are you disappearing, bruh? Rotate. Oh yeah, right, because once I translate it there, I can just draw it at 0, 0. Or actually, restore it right here. Actually, I could draw it at -50. -50. Am I getting an error here? CTX is not defined. Oh crap. It's called context, not CTX. There we go. So, let's comment this first. Looks right to me. I'm gonna say the height is whatever, 300, 400. And if I didn't translate and rotate, and I change this back to 100 looks fine to me. That rotation looked okay, so we'll try it out. So those are the basic steps. You first save, right? Then you gotta move the context to the center of the image, so that when you rotate the context actually kind of like rotates from the top left corner. So actually, let me take a screenshot of this. So here's what we're doing. All right, so think of the context as something that, you know, like a little machine, like I always say, a little machine that can draw on the canvas. When you do translate to this point right here, what you're doing is you're making so that the context lives here now, okay? Now when you rotate the context by, say, you know, math.pi divided by 4, which is 45 degrees, it's going to like live here now instead. So now, if at that point in time you draw the little blue square at coordinates -50 and -50, where's -50 on the x-axis right here, where's -50 on the y-axis right here. So this is your point, and this is where you're gonna draw the rectangle. So it's gonna be rotated, right? All you gotta do now to make sure that nothing else in the screen gets messed up is restore the context to where it was at the beginning. So you save it before you do any of those things, then you translate, then you rotate, then you do what you need to do to draw it, and then you restore it. This is how you rotate an image in Canvas. Where am I going to do that? In the render method. So, first thing I'm going to do is, well, ctf.save, right? I need to draw it right there, ctf.restore. And I'm no longer gonna compute render x like this, because I don't need, remember, once I move my context right here, right, I don't need to offset, you know, by x and y, by this dot x and this dot y, because it'll be like 0. So my render x and render y are gonna change like this, because all I want, you know, once I shift it, I'm gonna be shifting the context to this point where imagine the rectangle is the bird figure. I'm gonna be shifting the context to that point instead of, you know, keeping the context here so that its top left corner is at 0, 0. I'm gonna be shifting it to, I'm going with a different color now, to this point. So if my context is located at this point right here, like this one, that's rotated, then I need to draw. If I draw at 0, 0, my bird comes out right here. But if I draw at negative width and negative height, my bird comes out like right here, like the other square that I have drawn. So that's my plan. I know that's really hard to explain, so just try to, you know, make sense of it and ask questions in class if you don't get it. So before drawing the image, I need to translate the context and rotate it, right? So this dot ctx dot, oh crap, I need to do it. This dot ctx right here, and this dot ctx right here. This dot ctx dot translate this dot x, this dot y, and this dot ctx dot rotate. Well, I gotta compute the angle before I can rotate it. So angle equals, and let's start with this. I know it's got to depend on my vel y, right? So whenever vel y is, let me see, what's my minimum vel y when I jump? Vel y is -16. So if vel y is -16, I want this to be at its highest point. So let's try like this. This dot vel y divided by 16. Let's see what that looks like. And ctx dot rotate. I'm gonna rotate by the angle. this is gonna look like. Oh snap, it's not too bad. I think the inclination is a little bit too steep. So what I'm going to do is I'm gonna temper this a little bit. How about this? Math.pi divided by 3 times this. Math.pi divided by 3. So math.pi is pi, which is 3 times 14 divided by 3. It is actually more steep, so I'm gonna go with 6. There we go. Okay, I think that looks a lot better. So essentially, I'm saying math.pi divided by 6, which is 100 degrees divided by 6, which is 30 degrees. I'm taking the proportion of this velocity x to 16, multiplying it by 30 degrees. That way I'm ensuring that my maximum angle when I'm facing up is 30 degrees, and when I'm facing down, it can get pretty steep because this velocity can get way higher than 16. But that's okay, that's what we want. You see, by the time that the bird is kind of like, you know, close to the bottom, he's like nose diving, which is cool. That's what I wanted. Now, if we wanted to draw a game over screen, we could probably do it right here. Draw game over, right? And then I can just have a function here, function draw game over, and I can say, let me see, I gotta pass the CTX because this guy's gonna be outside of the scope where CTX exists. And let's go look real quick. HTML5 canvas fill text. I don't remember the name of the method, but I need to find an example so that I can see the parameters. Here we go. Verdana is my homeboy. And blah, blah, blah. Big smile. Game over. I can pass. I can pass a canvas here too, so that it can get its width and height. We're gonna see. This has a little bit of a problem. We'll see in a second. That's not centered. You see, it starts at the center of the screen. So let's see if there's a way. Fill text centered. There we go. Text align center. And now that should be good. There we go. So now we have our game over text. Our game actually ends. Now that we have that, I don't want to return. I don't want to freeze the game, you know, as soon as I lose. So there we go. That's how draw game over. Maybe I don't update the environment or the pipes. Maybe I move all of this to the top of the update method. And that way, oh no, I can't, I'm stupid. I'm gonna move the render to the end, because if I render the bird first and then the environment, then the environment renders on top of the bird. that's another big fail. What happened there? So we're not update pipes. If bird is dead, you lose and draw game over. Okay, I think what's happening here is, yes. So in the key listener, before I set the velocity to negative 16, I also got to check, hey, look, make sure that the self.dead is not true. Because otherwise I can keep jumping. And now that's more in line with what I wanted. And I can probably do a try to subordinate this to one else, because I don't want the environment. What I'm gonna do right now is I don't want the environment to move whenever the bird is dead. I just want everything to freeze, but the bird still to fall. There we go. Damn you. Filling this with 0. There's a way to do that. But if I do this instead, I don't fill that with black. Okay. There you go. So, game loop. Else, you render the environment anyway. Environment render. I'll do the updates first and the renders after. First, renders after. There we go. The game freezes. I get my logs. That's the way to do it. It's not what I wanted to do, but I mean, it's the first thing I thought about, but it's ugly, you know, because it feels like it's very redundant. But you know, what are you gonna do? So I think that's gonna be it for this episode. Actually, my game over text isn't drawing. I just realized. That's gonna be the last thing to render. So what I'm gonna do is, if this is not true, then I'm going to do all this stuff. If bird is not dead, then I update the environment. I update the pipes. Now, I render the environment, I render the pipes, I render the bird. And if bird is dead, then I draw game over. I think that's gotta be the ticket right there. There we go. Alright, so this time, for real, that's it for this episode. I hope you guys found it informative, and I'll see you guys next time.